Yeah, once again, good morning all. Good morning all. All of you, good morning.
Good morning, sir.
Yeah, in continuation of last class, we are discussing about transaction management. You know very well, here nowadays, without transaction management, there is no financial applications. So that we must understand the what is the importance of transaction management and how to implement the transaction management. And after implementation, if anything is loss or any problem is there, we have to recover the things. Okay, so that in this unit we are discussing about how to implement the transaction and concurrency, serializability, and recoverability techniques we are going to learn in this unit. So for that, we already discussing so many things. Here, what is a transaction and what are the transaction state and what is the transaction states. Can anyone tell what are the transaction states are available? When you are going to write a transaction, how many states are there? Hello? How many states are there in a
Five.
transaction? Yeah, what are those? What are those states?
Active, partially committed, failed, aborted, committed.
Yeah, very good. Here, active state, partially committed, and failed, committed, aborted. As I told you yesterday, here abort and committed. Here abort is nothing but transaction is completed unsuccessfully. Here committed is nothing but transaction is completed successfully. Means all the actions are executed. The transaction that is maybe it is a transaction committed. If any one of the action is not executed in middle, then the transaction is completed but unsuccessful. That is abort. Clear? All of it clear? Hello?
Yes, sir.
Yeah, before that already we discussed about asset properties, atomicity, consistency, isolation, durability. Here, as I told you, for any transaction, if you are implemented or if you are performing, that must be satisfy these asset properties. That is atomicity, consistency, isolation, durability. Okay, you know very well. Now, for this transaction state, now if you want to implement atomicity and durability, we have a mechanism that is shadow database mechanism. Yesterday we discussed about that. In this shadow database mechanism, with help of the shadow database mechanism, initially we can implement the atomicity and durability. We know atomicity, based on atomicity, we can achieve the durability as we discussed in the last classes. Can anyone tell what is atomicity? What is the meaning of atomicity? Quickly. What is atomicity? I'm asking what is atomicity? Hello?
Full execution will be done, or else no step will be carried out.
Yeah. Atomicity means if your transaction is having actions, for example, 5 actions are there, all these 5 actions must be executed successfully. Or if any failure has happened, it must be in the start page. Means either the transaction is in the starting state or execute. Okay, that procedure is called as atomicity. Now, if you achieve the atomicity, you will get the durability. What is the durability? What is the durability?
The value before and after transaction must be same.
The values before the transaction and after the transaction must be same. That is a durability. It means there is no data loss. Means you are performing some changes even though the data is not lost. So that is what the durability meaning. So that's why if you are really doing atomicity on your database, automatically you will get the durability because maybe your transaction may be the starting state or maybe in the last state. If it is here or here, that's why automatically you get the durability. The values, total value cannot be changed because the transaction is beginning either end. So that total value it never changing. So that here when we are going to implement a atomicity mechanism for your database, automatically it can be implemented durability. So that is the interlink thing. So now for this, if you want to implement atomicity and durability for the transaction state, here we have basic methodology that is a shadow database. Even this is sometimes called as recovery management as we discussed yesterday. In this shadow database is very simple. In this we have a database pointer. Always database pointer pointing to the current copy of the data. Here, if you are updated any data, then that is the current. Then the database pointer is pointing to that. If you are updated something, then it is going to move to the next. If any failure in this transaction is performing, any failure is happened as per the atomicity, that must be the starting state or that must be the ending state. So that if it is a starting state means it moves to back, the previous. The database pointer again moves to back. Like that, the database pointer is moving based on your update. Always the database pointer is pointing to the updated data. Here, if anything is going to failure, it moves back. Here, now this is very simple, but it is not possible for the large databases because if you are going to use large data, then we have to maintain a number of copies, more number of copies. If you are maintaining more number of copies means your hard disk size is going to require more. If the data is increasing, automatically the processing time is going to take more, and even this is a sequential. If you always it is going to work only with one data. So parallelly, concurrently, I want to perform more than one, it is not possible because data pointer is pointing always only one copy of the data which is updated one. So that this type of application, that is shadow database, is not possible for bigger databases. It is possible only for smaller databases. This is the disadvantage of shadow databases. Are you clear? Yesterday already we discussed about this. All of you clear this? All of you clear that? No. All of you clear this shadow database?
Yes, sir.
Right. Now the disadvantage is here it is not going to work with more than one at a time. So that is the disadvantage. To overcome that disadvantage, here our transaction management is implemented concurrent executions. Here, what is the concurrency? Here, like your operating system, what you are learning in your operating system, here that is a same unit. Already I told you we are going to cover same one unit is same in the operating system and DBMS. There we are going to use processes, multi-processing and multitasking. Here we are going to use here transaction, multi-transaction, multiple transaction. That is the different naming is different. And this is for database reader, that is for operating system purpose. Here the intention is same actually. So that's why. Tell me what is the meaning of concurrency? Any one of you? English meaning? General meaning. Technically, we will discuss. What is the meaning of concurrency? Quickly.
Two tasks happening at the same time.
Yeah. Here concurrently, simultaneously, we are going to perform more than one task in the same time, more than one task. That is a concurrency, correct? Is it right? At a time, we are going to perform. For example, you are listening and writing your notebook, whatever I am giving some instructions. Okay, that is called concurrency. At a time, two jobs we need to perform. Okay, that is what exactly the concurrency. Clear? At a time, you are watching video as well as listening as well as you are writing. Three jobs you are performing. That is what concurrency. Clear? Hello? All of you clear? Hello? Hello? I need response. I told you already. All of you clear about concurrency meaning?
Yes, sir.
Now, coming to our database management system, how we are going to use concurrency here? Here, generally, we know nowadays we are going to perform multiple tasks. Multiple people are doing are connecting same bank. For example, if you go for HDFC ATM machine, if you are inserting here in world, how many ATM machines are there? Here, how many people are there going to do the transaction concurrently? So many, right? Your ATM machine never tell, no, you wait some time. Here another transaction is going on. After completion of this transaction only, you need to do your transaction. Because I cannot perform a concurrency mechanism because I am a mission. Like that, it never tell. Here, whatever the transaction we are doing, multiple transactions are doing. Yes or no? Multiple people, multiple works, multiple areas, and same bank they are doing. Yes or no? Yes or no? Hello?
Yes, sir.
Yeah, that is concurrency. But come to the reality, really is it possible? Concurrency is possible, really? In your operating system also, that situation is there. Really, is this possible? Hello? Tell me. It is a mission, after all mission, it is possible for concurrency. Hello? Concurrency is possible. For example, if I tell you please execute program and write observation, a concurrent at a time program execution and writing is going to done in the same time. Tell me. Hello. When I am giving one instruction, immediately you are writing, or some space is there. When I am telling something, at the same time, whatever the word I started at a time, you are writing on your notebook. Is it possible? Hello?
No, sir.
No. The same way, mission also not possible. Concurrency is not possible. Even your operating system also same thing is there. Means here now I am simple meaning is here. For example, T1 transaction, T1 is doing and T2 is doing. So this screen is visible.
Yes, sir.
Is this yeah? Here T1 is doing its transaction. Now, when T1 is doing the transaction, now T2 has to wait compulsory. But when T1 is doing its transaction, it requires some data from the database. Now, maybe it requires A data, but A data is not there in the transaction. A data is there in the database. Now, what happened? T1 is connecting to the database to get the data of A. In that time, in this time, T1 is not doing any job. Yes or no?
Yes, sir.
In that process, now your operating system, this is the duty of operating system. Your operating system is going to allot T2 to do its job. Understand?
Yes, sir.
Then human beings are understood here. I am doing and T2 also doing. Here both are doing means here end users are not going to wait. If I tell no T1 is doing, you wait means your T1 after T1 only T2 will be start. Now what happened? A T2 sometimes he is going to wait, sometimes he never wait. That is the problem. That is what. Generally, the serializability means T1 after T1 only T2 will be do. But because of the operating system, T1 process is requesting some data from other sources. T2 is entering. Like that in our database management system also, a transaction one is executing. Any data is required, it is processed in that time. Our database management system, DBMS here, their operating system. Here DBMS, their processes operating system, their transaction and DBMS. DBMS is assigned T2 transaction to do their transaction. If it is required B data, then maybe if it is T3 is there, it is going to assign T3. Otherwise, your T2 is entered again here. T1 is entered again here for doing their transaction. Like that, the transactions are doing concurrent. It is actually coming to the reality, it is not possible. Same time, it is not possible because the same data storage, how we can, it is not possible. Yes or no? Yes or no? Are you understood now? Hello?
Yes, sir.
Same rule is applicable for your operating system, your multi-processing and multitasking. You people are, already scheduling algorithms in your operating system. If really you worked on operating system, this is very easy. Otherwise, you learn here and apply to the operating system. Maybe the namings are different and the theory and the formula and the procedure is same. Are you clear? All of you clear? Hello? Have you understood this? Yeah. Now, then why should we use this concurrent mechanism? This is another task. Here, why should we use this concurrent task? Means here T1 is doing this transaction, but T2 has to wait until T1 completes. If T1 is required a data from database, but A is not provided by database because the data loss is happened. Then what happened? T2 has to wait until T1 completes. Maybe I don't know how much time it is going to take. That means here we are increasing the processing time, and even here T2 is going to feel still my job is not started. I have to wait. How much time I need to wait? Like that. Here the end users are not going to interest. Instead of that, if you make it as a concurrency mechanism, when T1 want to take data from other sources, that time T1 never do any job. In that time, you can allot T2. Then T2 is going to finish at least some of the part of the job. It is some part, here it is some part. So that what happened? At T1, T2, here some process is going on. So that, for example, if I tell you, if you entered ATM machine, you are given your ATM card here, insert your ATM card, here one person, P1 person. And it is going to ask, enter PIN number or something. Up to this, it is done with this ATM machine only. So that in the time, when it is going to ask enter money, here we are entered account information. Means I want to withdraw 20,000. Now it has to check the 20,000 is available or not in this account. It needs to connect to the bank database, server database. At the time, T1 transaction means that ATM cannot do the process. Then another ATM, it is going to queue. Here, it is there with what it is happening. Here, enter credit card, debit card, and something will do. Again, you want to withdraw some amount, then again move to the database. In this time, this is free. Now T1 is data is come back and it will be continued. Now this here like that here concur people end users will understand here our tasks are doing concurrently, but generally it is doing sequentially. I will show you. Even don't worry about this. Have you understood? Here for this process means here we are improving the performance. That is nothing but throughput. This is very important name in an operating system. Throughput means your execution of processes. Your very less time. How much time it is taking to executing of the processes is called as throughput. The same way, here also we are going to use throughput. Here executing of a time required to executing of transactions, total transaction is called as throughput. Here, using this concurrent executions, our throughput is going to increase. Means all the transactions are going to execute more faster. That is the advantage. Now understand why concurrent transactions are required. Understood everyone?
Yes, sir.
Otherwise, we need to wait 2 to 3 days for our transaction because so many people are there. Yes or no? Yes or no? Hello? Yes or no? When you want to withdraw 20,000 from your account, you need to wait 2 days if there is no concurrency mechanism. Yes or no? How nowadays people are waiting in a vaccination queue, like that you need to wait for withdrawing of money. Understand?
Yes, sir.
Yeah, because there is no concurrency. But here the mechanism is implemented based on the transaction management. Now concurrent execution. Already I told you multiple transactions are allowed to run concurrently in the system. Exactly, multiple transactions. We are allowing to execute the things. So that is what concurrence mechanism. Here, what is the use of this? Here it is going to increase the processes. Here, the process speed is going to increase and utilization of this more utilization, more processes are running, you are utilizing so that we can get the throughput. Already I told you here how much time it is taking to execute multiple processes is called as throughput in your operating system. The term is very important. Do you hear the throughput in operating system? Hello? Hello? Have you heard throughput in operating system? Respond, yeah. If you are not responding, what I can think? Have you heard throughput term in your operating system or not? Hello? Hello? What is going on? Is this my voice is audible? Hello? Hello?
Yes, sir. Audible, sir.
Yeah, what I am asking, the throughput is your heard or not in the operating system? Again silent. The throughput
Sir.
word, yes. Here now same meaning, same things are going to work in the database also. Please try to respond. Otherwise, I will stop the class. What is the use? How I know you people are following or not? Here, no one simply idle. You are sitting and enjoying. It is very important. It is you are when you are going to enter any job, compulsory these things are going to help a lot. Right. Now, as I mentioned, the transaction can be using with CPU while another is reading from or writing to the disk. Just now I told you, just now, here, when something we are doing here, then anything is required, it is moving to other IO devices, it is going to move. At the time, this transaction, the processor is idle, so that the T2 is entering and it is doing the job. Here, this is what exactly it is going to happen in a concurrency manner. Here, the concurrency mechanism, already I told you, here we can have so many techniques, because without using any technique, you cannot achieve the concurrency mechanism. Because if you use T1 and T2, I want to execute concurrently, then again some data will be lost. That's why we have so many mechanisms, so many techniques in the transaction management system to maintain a data consistency. If you are executing without any mechanism directly, I want to execute multiple transactions in the same time, there is a chance of data inconsistency. For that, we need to follow some of the mechanisms and techniques. One by one, we will discuss. Based on that only, we can implement the concurrency mechanism. Are you clear? Are you clear? Why should we use concurrency? What is concurrency? Right. Now, when you want to implement a concurrency mechanisms, here we must learn schedule. Here, how to prepare the schedule and how we are going to manage the schedule. If you really understand schedule, here in your operating system, it is a scheduling techniques are there. Here in this transaction management system, database management system, we need to prepare a transaction with the help of schedules. Here we have different categories of schedules. Schedule is nothing but a procedure, step-by-step process. Nothing is there. Don't confuse. Very simple. Already we discussed the schedule, but we don't know that is the name is schedule. Already we know the procedure. This schedule is a sequence of instructions that specify the chronological order in which instructions of concurrent transactions are executed. Nothing but this is a schedule. A T1 transaction, first you need to read, then detect, then write, then read, then do this, then do this, then do this. This is called a schedule. Nothing but your timetable is a schedule. If you are not provided any timetable for you, here so much of data conflict will be occur. Here everyone is going to join the same hour. Sometimes no faculty is going to take any class. That's why if you are having schedule, everyone, even student and faculty, they will follow the schedule. Same way, here you want to perform our transaction, you must be first create a schedule. That schedule must be right, so that there is a chance of concurrency execution. Before entering concurrency execution, we must prepare a good schedule. That's why we need to understand how to prepare a schedule. Just now I told you the sequence of instructions that specify the chronological order in which instructions of concurrent transactions are executed. A schedule for a set of transactions must consist of all instructions of those transactions, and it must preserve the order in which the instructions appear in each individual transaction. This is very important. The order must be important. Whatever the order you are writing, the instruction in a schedule, the schedule is going to execute in the same order. That's why if anything is missing, then a lot of financial things are going to happen. That's why please follow and understand the schedule. Based on the schedule, you implement your transaction so that there is a chance of concurrency mechanism. Here now in this transaction preparation, schedule preparation, here always the end of the transaction means you're writing instruction 1, instruction 2, instruction 3, instruction 4, instruction 5, instruction 6. Now, if you are preparing like that, the end of the transaction, we need to write a commit statement. Means all actions are going to execute it successfully. Then you need to write commit. Commit means already I told you all actions are executed successfully. That is called transaction is executed successfully. That is a commit. If any failure is happened, in a transaction, maybe because of any failure, maybe the power failure, system failure, something. Again, we need to add a bot. End of the transaction, we need to add a bot. Means end of the transaction in a schedule. If you are preparing a schedule, this is a schedule. one by one you are executing, but end of the transaction of the schedule must contain either commit or abort. If the transaction is executed successfully, the commit is going to execute. If the transaction is executed unsuccessfully, abort is going to execute. So this is what the schedule. Now understand, all of you, how to write the schedule? All of you understood? Hello?
Sir.
Yeah. Now, here, please be careful, carefully understand and reply. If any doubt is having, please ask me immediately. Very important, please. Because if you understood the schedules, your next sessions are very easy. Now, for example, this is the case study. Let T1 transfer $50 from A to B and T2 transfer 10% of the balance from A to B. So this is what the case study we need to perform for the schedule, how to prepare the schedule. Here, simple, here T1, T2, two schedules we have taken, T1 and T2, two transaction, this is a schedule 1. Here, what I am going to tell in this case study is, here, how many ways we can prepare the schedules I am trying to tell. Please understand. Are you clear? Here, the schedule preparation is right. Here, we can prepare more than one way. Here, all are right. Which is right, which is wrong also, you can observe here so that we can understand how to write the schedule. Here, the preparation of the schedule is very important. Are you clear? Are you clear? Hello? Just now we learned what is the schedule, how to write the schedule. Now I am going to show some case studies, how to write the schedule and how to not write the schedule. Are you clear?
Yes, sir.
Yeah. Now, for this example, here I need to transfer $50 from T1 in a T1 transaction. It is a concurrence, right? At a time, I want to execute these two. Understand? T1 and T2. Like that, you can take T3, T4, T5 also. Are you clear?
Sir.
Yeah, concurrently I am doing, but here how we are going to prepare the schedule without any data loss. Here, this is what our observation. Now $50 I want to transfer from account A to B, and in a T2 transaction, what should I do? 10% of the balance of A I am transferring to B. So this is what. Now I want to prepare. Now in a T1 transaction, I prepared a read A. In this time, there is no any transaction in T2 side. Yes or no? Yes or no?
Sir.
No problem. Then there is no concurrency. A equal to A minus 50, write A, read B, B equal to B plus 50, write B. Then what happened? Is there any data loss is going to happen? Because in this case, up to this case, there is no any instruction or any execution in the T2 side. So that there is no chance of concurrency execution. Yes or no? There is no data loss. Yes or no? Hello? Is there any data loss?
No, sir.
No, sir.
No, because T2 is waiting for execution of T1. Okay, not a problem. Now our job is done. First job, what is that? $50 we are transferring from A to B in a T1 transaction. Yes or no? We are transferred, right? We are transferred, right, for A1 T1 transaction.
Yes, sir.
Hello? Yeah. Now coming to the T2 transaction, what is the task? Transfer 10% of the balance from A to B. Now read A, here we have taken one temporary variable for calculation of 10% of A balance, that is A into 0.1. Here now we are detecting 10% of A balance, that is A equal to A minus 10, then write A, then read B, then adding the temp to B and write. Now in this time there is no any action from T1. So that here there is no, this is a sequential, there is no concurrence actually. Here, so that there is no data loss. Here, whatever the task we are assigned, it is done. Understand? It is done or not? Task is done or not based on the schedule. Hello? Quickly, time is running. Whatever the task is assigned, it is done or not based on the schedule. Please, if possible, try to write these schedules also in your notebook. Hello? Is this clear?
Yes, sir.
Yes, same for same case study. Here we can create another way of schedule also. That is schedule 2. I am telling same case study. Here I am not changing here. Here what happened? The first case study. Here T2 is waiting until T1 completes. Here now another guy is written. Here, sir, I don't want to do like that. I want to like do this. Here T2 is performing first, then T1 is performing next. Nothing is there. Means here T1 is waiting until T2 completes. It is also a serial schedule, right? Because here T2 is waiting until T1 completes, and this is also same. T1 is waiting until T2 completes. So this is also a schedule which is a serial schedule. Both are T1, schedule 1, schedule 2 are serial schedules. Both are same. Yes or no? Hello? Hello?
Yes, sir.
Yes.
Yeah, both are same. Who can write? Okay, both are right. Both are serial schedule. Now another guy wants to do the same actions in another way. That is, he prepared schedule 3. Here what I am telling is here how to write the schedules I am showing. Please, here is schedule 3. Now in the schedule 3 they splitted their actions in multiple ways. That is, T1 first. T1 is taken read A, then A equal to A minus 50, then write A. Are you clear? Up to this clear? Means he has deducted $50 from A. Then he is wait. Means he is not doing any transaction, just he is hold. Then T2 is came to the picture. Then read A, calculate the 10% of A account balance and deducted 10% from A account and updated, means write A. Now T2 is done. In this time, there is no disturbance, there is no any data loss from T1 side. So that T1 is done successfully. Yes or no? Yes or no? Hello? Hello?
Yes.
Now after T2, then T2 is hold, then T1 is started its action. Now whatever the $50 is deducted from A, now it is going to transfer to B. Read B, B equal to B plus 50 and write B. Then this is done. Then T2 is going to start. Whatever the 10% of A balance is deducted, that is going to add to B, that is read B, B equal to B plus 10, write B. Now this is done. Now schedule 1, schedule 2, schedule 3, all these 3 are same. It is transferred amount from A to B, $50 in a T1 transaction, and 10% of A balance is transferred to B account in a T2 transaction. All are done same job. Yes or no? Schedule 1, schedule 2, schedule 3. All are equal actually. Yes or no? Hello? All are same or not? All are same. They did same job. Yes or no?
Yes, sir.
Hello? Yes. But when you comparatively, schedule 1, schedule 2, schedule 3 is somewhat different. Yes or no? Result is same, but the procedure is different. Yes or no?
Yes, sir.
Means just we are shifted some of the instructions in another order. So that what happened in schedule 1 and schedule 2, here one of the transaction is not going to start by another transaction is going to complete. If you go to the schedule 1, the T2 never started until T1 completes. In schedule 2, T1 never started until T2 completes. Correct? Is it correct?
Yes, sir.
So T1, schedule 1 and schedule 2 are purely serializable schedule. If T1 is having any problem, if it is going to struck here, the T2 never start their job. Here, this T1 is not having any problem, but T2 has to complete. Here T1 is having any problem here. Now T2 never start the job. So that is the big problem. Are you clear? It must be complete. Then only it will be start. Yes or no? It is purely,
Yes.
both are purely serializable. Yeah, this schedule 3 also serializable, but it is equivalent to schedule 1, but it is not a pure. Here now, T1 is going to perform some job. It is not completed, even though T2 is started. Then what happened? Here at T1, the job who is going to doing this transaction, T1 and T2, these people, maybe this guy is person 1 and person 2. So this P1 and P2 will be think, okay, my transaction is running, my transaction is running. So both are going to satisfy. Understand? And even though partially it is committed, here partially committed, here partially committed. So some of the actions are going on. Are you clear?
Yes, sir.
Yeah. Here this type of schedules are best comparatively schedule 1 and schedule 2. So this schedule 3 type of schedules are maybe it is best for the transactions to perform more and get the more throughput. Are you clear? Are you clear?
Yes, sir.
The differences. Yeah. Now coming to the schedule 4. Here another way of schedule. Sir, we have written this. Here even I want to write this way. Schedule 4. Here how they have written. Just check it. Here T1 read A equal to A minus 50. Please careful in a transaction P1. Same. I have taken same number of operation T1, number of operation T2. Same, but I am just splitting. Here coming to the schedule 4. Here T1 read A equal to A minus 50. What happened? You are deducted $50 from A. Yes or no? You are deducted $50 from A. Yes or no? Hello?
Yes, sir.
After deduction, you are not updated. You have not write A, right? Means what is the meaning? For example, initially A is having $100. You take like this. Now A is now $50. Please careful. Now read A. So I want to read A. Now A contains how much now? Tell me. 100 or 50?
50.
50 only. Now here percentage, 10%. What is the 10% here? What is the 10% of 50? Hello? 5, right? Hello?
Yes, sir.
Yeah. Now A minus 50 means A contains how much? 45. Now, yes or no? Yes or no?
Yes, sir.
A contains initially 100. Just I am writing B contains initially 100. Okay. Now write A. Okay. Now A is updated. A contains now 45. Now read B. Here read B. B is having 100. Now you move to the T1 transaction. Write A. Here write A means A is updated with how much amount?
45.
A with 45. Now read B. What is the B value?
100.
100. Very good. Now 100 will be updated with 150 and write B. B is updated with 150. Done? Yes or no? Yes or no?
Yes, sir.
Hello? Now T2 transaction. So B equal to B plus 10. How much? What is the B value now? What is the B value?
150.
150.
150 plus, what is the temp? What is the temp?
50.
5. Temp is how much here? 50?
5, sir.
5.
5. Then write B. Here means how much? 155. Yes or no? Hello?
Yes, sir.
Here now, same things we can apply here. Here read, this is 100, you know, A 100. Then what happened here? 50 is updated here. Now read A. Here what value are going to read here? How much value are going to read here? A value. Hello? Hello? What value are reading here? 50. Now temp equal to A into 50. How much? 5. Here A equal A minus temp means 45. Now we have written. Now read B. Then it will come 100 here. Now B equal B plus 50. How much here? 150 will be updated. Now read B. Here what value are reading here? 150. Now B equal B plus temp. How much? 155 will be updated. When you are going to observe here, A equal to A minus 50 means here we have not written actually, just we have detected. But A value is how much here? Not 50 here. Actually, it is 100. We are confused. Because when we are going to write A equal to A minus 50 is nothing, but we are detected, but we are not updated. We are not written right statement. Here we are not written right statement. Then it never come 50. It will become 100 only. Are you clear? Are you clear?
Yes.
Now 100. Now temporary value will come how much? Yeah, 10 here. Yes or no? Yes or no?
Yes, sir.
Now here how much value? A now get 100 minus 10. How much value? It will get 90. Then write A. Here A value is updated now 90. Clear? Clear?
Yes, sir.
Now read B. Here B is how much? 100 we are reading, right? Very good. Now write A. Now we are writing A. What value are going to write into A now? Not 45. What value are writing? A. Where is the A? 90. Yeah. Don't confuse because there is a missing. When you are changing anything, you must be updated using right operator. Here we are missing right operation. So that's why 90. You write A. Now A value is 90 now. Read B. Read B means B value. We are updated anything? No. Only 100. Okay. 100 not a problem. Now what you have to write here? B equal B 150. Then it is updated because we have written right operation 150. Now here B equal B plus temp. What is the B value? 150 plus 5. Okay, this is good. Temp is how much? Not 5. Temp is how much? 10. Then how much will come? 160. Yes or no? Yes or no?
Yes, sir.
Now what is the A value here? 90. What is the B value here? 160. What is the total? What is the total? Hello? 250. Is it right? Hello? Are you following? Hello?
Yes, sir.
Yeah, 250. Now come to here. Here, what is the A value here? After this? What is the A value? 50, right? 50 or 45? What is the A value after execution? I am asking. Hello? If you are following, you tell. Otherwise, you ask me, I will explain again. Hello?
It's 45, sir.
Oh. Then what is the B value here? What is the B value here?
150.
155. Correct?
Yes, sir.
Yeah, what is the total value? What is the
190.
total value? Huh?
190. Sir. 200, sir.
90 or 200? 200.
200.
Now, total is 200. And before starting transaction, how much? A plus B? 200. Yes or no? A plus B, how much? 200 before starting. Here, after completion, 200. Then the transaction means durable. Now the transaction is right because of the schedule. Yes or no? Yes or no?
Yes.
But comes to this because of the schedule. Here, before the transaction is 200, then after the transaction completes, how much you got? How much?
250.
Then your transaction is durable.
No, sir.
Means here when you are writing your schedule, you must be aware, you must be check how we are writing so that this transaction cannot be preserve the A plus B value durable. That's why the schedule cannot be worked out. Here when you are going to write any schedule, here when you are going to change something, you must be right, you must be do the right operation compulsory, so that only the data will be updated. If you are not doing right, read A equal to A minus 50. You are just deducted, but you are not written right A. If you are not written right A means that it is not stored in the database. A equal to A minus 50 means you are performed the operation. You have deducted the amount, but that you have not written here. Immediately you have taken T2 transaction. Here, if it is looking like just you are swapping the operations, but you are not followed the rules, so that this schedule cannot be provide the durability of your transaction. That's why while writing schedules for your transaction, you must be aware all these things so that finally we will get the right transaction. No one will be lost. Are you clear? All of you clear?
Yes,
All of
sir.
you clear
Yes,
about
sir.
this? Clear about these schedules, how to write and how to check? Clear?
Yes, sir.
Yeah, please. Here, for the paper and for the class, for the space, I've taken only 2 transactions. Even you can write a number of transactions in a schedule, not a problem. Don't think, sir, we have explained only 2 transactions everywhere in a schedule, but exams they are asking more. No, you can write many number of transactions in a schedule. Yeah, but every schedule must be follow some rules and regulations so that you can understand how to write the schedule and how to it is going to implement. Clear? Clear?
Yes, sir.
Right. Now that is a concurrency way how to do. We will learn after that concurrency after this serializability. Very important point, serializability. Everyone knows the meaning of serializability. Yes or no? What is the meaning of serializability? Tell me. Hello? These 2 slides I will complete it. Serializable. Tell me the English meaning. Hello? What is the serializability? Hello? Hello? Is this my voice is audible? Is this my voice is audible or not? Hello?
Yes, sir.
Is this my voice is audible? If yes, this why you are taking this much time? What is serializability?
Multiple transactions are running concurrently. The possibility of data is left in an inconsistent state.
No, Ram Challa, it is not like that. Serializability is nothing but serial, one by one. If you are having multiple transactions, you are going to perform one by one. First transaction completes, then second is entering, then third is entering, then fourth is entering. The serial, one by one, that is a serializability. Are you clear? With help of serializability, we can implement the concurrency. I will tell you, first of all, understand serializability. Are you clear? Your classwork is conducting serializability way or concurrency way. Your timetable classwork is doing concurrently or serializably. Hello. Sir, at the time of attendance also, you please in this mode only you tell attendance. At the time of attendance calling, no one will be respond. That will be good. That time everyone will work, everyone minds will work, everyone will respond. Your phones will be respond, everything will be respond. Understood serializability?
Yes, sir. Yes, sir.
Now, based on serializability, we are going to implement the concurrency. So that we need to understand what is serializability. Here already I told you the basic assumption, already I told you the serial execution of set of transactions preserve database consistency. If we execute your transaction serial way, only our database must be preserved. If we are going to forget about serializability at the time of concurrency, then how it is possible, sir? How we are going to execute concurrency with help of serializability? It is possible, some mechanisms are there. I will tell you one by one later, don't worry about this. For this serializability, we have two types of categories of serializability. Very important, this topic. One is conflict serializability. Another one is the view serializability. Here, conflict serializability and view serializability, two categories of serializability techniques are there in this transaction management. One is conflict serializability, another one is the view serializability. Okay, here how the conflict serializability will work and how view serializability will work, we will discuss in the next class. Don't worry. Very important, if you understood really the serializability mechanisms, then we can apply the concurrency mechanism for the transactions. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah.